Okay. So we're going to evaluate rational numbers. So we'll evaluate them, but we're also going to leave them as an exponential number with a fractional exponent, which is also known as a rational. If you take a look here, what's difficult about this question is we have a fraction for an exponent and we have a decimal for an exponent. Even if you're doing like adding, subtracting, dividing fractions or decimals, you essentially want the same type of number. You either want it to be a rational number like this, or you want it to be a decimal value. So we can convert this to a decimal and then apply our exponent rules, or we can convert this to a fraction. Now, because we're talking about rational numbers, they probably want it as a fraction, and the reason being is when exponents are written in fractions, it's actually really easy to turn them into a radical. It's a simpler thing. When they're decimals, we don't usually carry out that calculation by hand. You would use it like you punch into a calculator, and essentially what it's doing is it's finding a root and an exponent all at once. So I'll try to explain what I mean. That's actually what I'm doing. Anyways, let's do this one here. So 0.3, we can convert this into a fractional value. So 0.3 is essentially 0.3 over 1. Any number can be written over 1. So what we can do is we can multiply this. Since we want the decimal value to go over 1, we'll multiply both the top and the bottom by 10. So what happens here is the decimal value goes over 1. So essentially 10 times 0.3 is just 3. And 1 times 10 is 10. So really quickly we've turned this into a fraction. So now we can rewrite this question. 4 to the 5th times 4 to the 3 over 10. Perfect. The bases are the same, so that means we can apply our exponential rules. Because it's multiplication, do you know what we would do with the... yeah, we'd add them together. So our base is the same, and then we have 1/5 plus 3 over 10. Now, to add fractions, we need a common denominator. This is base 10, this is base 5. Luckily, you might recognize really quickly that base 5 can be turned into base 10 by just multiplying by 2 very quickly. So we'll get 2 over 10. So we get 4, 2 over 10 plus 3 over 10. And that's going to give us 4 is equal to 5 over 10. Now let's move it over here. 5 over 10, we could technically write as the 10th root of 4 to the power of 5. The 10th root of something, like just off the top of my head, I don't know 10th roots. It's really, really difficult. But because this is a fraction that we can reduce, we can rewrite this number as, or I don't even have to write or, but I can write equal to. 4 is equal to, I can divide both of them by 5. This is a fraction of a half. A half is much simpler. I can rewrite that as the root. A half is technically a root of 4. Technically what it is you put the denominator on here, so we're looking at the second root, and then we technically say to the power of 1, but anything to the power of 1 is the same thing, so we tend to leave that out. So now what's the root of 4? Well, the root of 4 is 2. So this very complex looking thing can just be written as 2. We could have went the other route. I'm going to quickly do it in purple, since we discovered that color today. I can turn this into a decimal. Now, I know off the top of my head that decimal is 0.2, and then 0.3. We can apply the exact same rules. 4 is equal to 0.2 plus 0.3, which is equal to 4 is equal to 0.5. 0.5 as a fraction is a half. But if I was going to do 0.5, I would probably just punch it in a calculator. You'll end up there, but it's much easier to work in our fractional answers. That's why they've given us rational numbers. So let's try another example here. Maybe a more difficult question. Let's see, do you have any with different bases? Okay, let's try the last one there. So we have 8 to the power of negative 2 times 8 to the power of 2.5. Okay, that gets a little tricky. Over 8. So luckily the bases are all the same in all these. Sometimes even when bases are different, we have to do a little bit of converting. In fact, I'm going to change this question just a little to... what's a good value? Let's say... no, that's not a very good value. 2 to the... what was the original one? 6? I'm going to say 12. Okay, so I did a little conversion there. So here's our new question. We have to simplify and express as a rational number. So like we talked about before, we have some decimal values. I'm going to turn them into fractions. These whole numbers can be turned into fractions very simply. You essentially just say over 1, but we don't need to do that. It just makes everything a fraction, which is nice. So I'm going to quickly convert the 1 over here. We have 2.5. Technically, it's over 1. Anything times 0.5, I can actually just multiply by 2. So I'm going to multiply the top number and the bottom number by 2. So this will be over 2. 2.5 times 2 is actually 5 over 2. Okay, that's fine. That works as a fraction for us. So we can replace this with 5 over 2, which we'll do in the next step. And then this is a negative, so it'll stay a negative, but 0.25 over 1. 0.25, I know off the top of my head, is kind of like a quarter. So I know I can multiply both the top and the bottom by 4. I'm going to get over 4, and that's going to be 1. 1 over 4. So we're going to replace this. Yeah, go ahead.
Can you leave
as a decimal?
2.5 over 1 as a fraction?
You could. The problem is fractions are simplest to work with when they're integer values. In other words, like natural numbers, whole numbers.
Okay.
When integers are whole numbers that have negative and positives. So that's why we leave them that way. You could write it as decimal. It gets really confusing to work with fractions as decimal. We just tend to turn them to whole numbers, and then it's much easier to apply all of our fraction rules. But technically, you can work that way. Okay, so let's rewrite this question. So now we have 8 to the power of negative 2 times 8 to the power of 5 over 2. That's a little different now. Divided by 2 to the power of 12 to the power of a quarter. Great, so our exponential rules, we know that this is multiplication. So because those bases are the same, let's do a little shrinking here. Because those bases are the same, we can write it as one base, and we're just going to add the two exponents. So negative 2 plus 5 over 2. Okay, so this is where we run into a problem. We need a common denominator. The denominator of negative 2 is technically over 1. So quickly on the side, I'm going to go negative 2 over 1. I need to make it a denominator of 2, so I'm going to multiply both the top and the bottom by 2. So this becomes 2, and this becomes negative 4. So we can rewrite that part. And technically, I should write the whole question each time. 4, so we rewrite it now. Now it becomes 8 with negative 4 over 2 plus 5 over 2 divided by 2 over 12. Problems with these questions is they're so vertically large, like the characters and symbols.
Yeah.
Sometimes what you can do, and I should have done it this way, sometimes what I'll do is I'll just highlight a part of my screen. That's not highlighter. This is a highlighter, I'm pretty sure. No, I lied. That's a highlighter. There it is. What I would do is highlight part of the screen and just like work on that on its own. That way I'm not taking up so much of the paper, but it's fine.
Yeah.
Let's go back. So we can now work on just this adding of this fraction. I'll do it in purple again. So negative 4 over 2 plus 5 over 2. Well, we know the base will be 2. Negative 4 plus 5 is actually just 1, so it becomes a half. So great. The very next step to this is 8 to the power of 1 over 2 divided by 2 to the power of 12 to the half. So when we have an exponent of a power, do you know what rule we use for that?
Adding.
Adding is we're multiplying them, but this is an exponent of an exponent.
Oh, you would. Oh.
You're not sure? That's okay. We multiply. That's the rule for that.
Okay.
So what's nice about this is multiplying fractions is actually, in my opinion, much easier than adding. So we have 12. I can turn it into a fraction. It's 12 over 1 times 1 over 2. We don't need common denominators or anything like that. When we multiply, we just do the top value by each other and the bottom values by each other. So this becomes 12 over 2. And I can reduce 12 over 2. 12 divided by 2 is actually just 6. So now that becomes 2 to the power of 6. So we have 8 to the half over 2 to the power of 6. Now, this is where I've run into a bit of a problem. I'm going to shrink it just a little more. My bases are not the same, so I cannot use like my division rule. But 8 can be written as base 2. So I got to think about it. It can be difficult to figure out. And sometimes we have to find a different common base, but if we think of powers of 2, 2 to the power of 1 is 2. Well, I'll write 0 up here because it's just important to know. So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And 2 to the power of 3 is 8. Perfect. What that means is I can replace that base 8 to the power of 3. So we're going to replace now just this part. And what happens here is you get, I'll replace it in red, 2 to the power of 3, but it's still to the power of a half, which is important, okay? And we have 2 to the power of 6. Great, now we're working with the same base, but we still have another operation we have to carry out here. It's a power of a power, so that's multiplication again. So it's 3, which we know as a fraction is 3 over 1, times 1/2. So we do top by top and bottom by the bottom. 3 over 2. Great. Kind of all over the page here. We really tend to work vertically, but that's okay. So this is going to be 2 to the power of 3 over 2 divided by 2 to the power of 6. Okay, the bases are the same. Man, I just have to keep shrinking. Bases are the same. I'm going to work with it over here. So the answer is going to be base 2. But because it's division, do you know what we do with our exponents?
Subtract.
Yeah. So we have 3 over 2 subtracted by 6. Well, turn 6 into a fraction. And I got to make sure I have a common denominator. So I'm going to go to the top right corner up here. The denominator is 2, which since our denominator is 1 here, it's pretty easy. We just multiply both the top and the bottom by 2. We get 2 as the denominator and 12 as the numerator. So we rewrite this part. 3 over 2 subtract 12 over 2. We're still going to get base 2. 3 subtract 12 is actually a negative value. It would be negative 9 over 2. So, to the power of negative 9 over 2. This is a fraction we can't reduce. I can write it as a radical. Sometimes they'll ask you to write it as a radical. So if they say write it as a radical or in radical form, that's going to be the root of 2. So root 2 of base 2 all to the power of 9. And technically you can say, so it's technically negative 9. And to get rid of that negative,
Flip it.
exactly. So this actually, to keep that positive, be 1 over 2 to the power of 9 over 2. And same thing here, we would just put it over 1, shrink it a little more, is equals 1 over root 2 of 2 to the power of 9. Both of those things are equivalent. A lot of side work. Sorry that the flow of this question kind of went like sideways and around because we ran out of space. But does that make sense for the two of them? Okay, good.